Okay, good afternoon. So I'm doing a short little mini lesson on how to tell if a function is proportional linear. So let's look at four quick examples quickly. Okay, so if we're seeing about our different forms, we're going to look at a table and try to determine if a table is proportional linear, and a graph and try to determine if a graph is proportional linear. The table is definitely the harder of the two. So for a table to tell whether it's proportional linear, and I'm really kind of looking at these as separate words here, the table has to have a constant rate of change and a constant ratio. All right, reviewing what rate of change is. So looking back in these notes, we have ROC, rate of change in Y over change in X between every 2 points. So we're going to look in the change in Y, divide it by the change in X between every 2 points to see if it is constant. All right, now proportional linear, these are the notes I had given to my students. Proportional linear, the ratio has to be constant all the way through. So you have to do the individual Y divided by X for each point to see if it is the same all the way down the table. Looking at number 1, or I didn't number it, but I'll number it now. Okay, so we have to first determine if it's linear. It's kind of written out of order, but you first determine if it's linear. So we're going to do that constant ROC. So we're going to look at the rate of change, and I have a separate lesson on, just finding the rate of change to see if it's linear, so check that video out. But, so I'm going to go through this a little quickly. If you need a little bit more on whether just a table is linear or not, doing this ROC, just go and find the video how to determine if a function is linear. But going over this ROC is that change in Y over change in X. So my Y's are on the right, and to get from 0 to 5, I go up 5, and from 0 to 1, I go up 1. Okay, so that ROC, that change in Y, and that sign I'm writing right here is delta. It just stands for change. The change in Y is up 5, up 1, which simplifies to 5. So every change that I do from here on out needs to simplify to 5, or it's not even going to be linear. So now let's look at between 5 and 10. So we don't start and go here to here. We start with that second point and go second point to third point to see if that rate of change is also 5. So 5 to 10 is up 5, 1 to 2 is up 1, 5 over 1 again. As you can see, my table is continuing to increase by 5 and continuing to increase by 1. So every ROC is going to be 5 over 1. So it's definitely going to be linear. Now, the second question is that proportional? Okay, so when I talk about the ratios, each individual ratio equal to each other. And I will say something. Whenever you have this 0, 0, if I do 0 divided by 0, it's going to come out to be, well, it's actually undefined because of the 0 on the bottom. So don't ever use this initial origin point. Start with your 1, or start with anything other than 0, 0. So we're going to do each individual Y divided by X, okay, and see if they all come out to be the same thing. So I'm doing that constant ratio. I'm going to put my work below the graph. Y divided by X. So 5 divided by 1, which obviously simplifies to 5. 10 divided by 2. 15 divided by 3. 20 divided by 4. And 25 divided by 5. If we divide these out, they all equal each other, and they all equal 5. So we can say in my answer that this is linear, proportional, comma, constant, ROC, and ratio is 5. All right, let's look at this second example. Okay, first have to determine if it's linear. So as we glance at this, all of our x's are going up by 1 every single time. So if all of our x's are going up by 1, in order for the change in y over the change in x to be the same every time, that change in x is going to be 1 every time, which means the change in y needs to be 1 every time for this to have a constant rate of change, for it to be linear, is what we're checking right now. Well, if I look from 5 to 7, that's up 2, up 2, up 2, up 2, up 2. So we do have that it's linear, with that constant ROC being 2, okay? And I'll put ROC equals just to kind of remind you of what we're doing here. Now, let's check about proportional. Once again, let's set up our ratio. And we need to do each individual. And remember, don't use the x0 point. Don't use that y-intercept, which is what that is. Start with x is 1. So I do my 7 over 1. And immediately when I go and do my 9 over 2, I already realize 7 over 1 simplifies to 7, and 9 over 2 simplifies to 4.5. So these are not going to be equal. Therefore, this is linear, okay? ROC equals 2, but not proportional. Okay, so that means if I were to write an equation for this, this would be in slope-intercept form. So if you need to know more about slope-intercept form, look for my videos on that as well. Now, real quickly, let's review the graph. It's simple. If you have a graph, if the line goes through the origin, it's proportional. If it does not go through the origin, it is not proportional. So this one is a yes, it is proportional, and this one is a no, it is not proportional. Okay? All right, if you know anything about me, so if you are my students, you know that I love to get a good workout in and then have a good snack. So if you are at home studying, then I encourage you to go get a good workout in, do a run, do a workout video, have fun, and then prop your feet up in the chair with some Cheerios and M&Ms and a Diet Mountain Dew and do your studying and make it relaxing.